If you watch my last video on, or one of my videos in regards to the switching, fancy switching it's called, and this was the actual circuit here. I had an originally I had a push button right here in this place where you see these wires to activate this side of the circuit that switched these LEDs. These LEDs simulate a double pole, double throw switch. And what I've done is I've removed them in favor of adding this circuit right here. Now what this thing is doing is it's activating the lights according to sound. This is an electric microphone, and I've added a couple of transistors here for amplification to amplify this substantial enough so that it would be picked up by the chip here and then activate the outputs. Now, this is not sensitive enough for voice operation because, it's just the sensitivity is not there. I haven't added enough. And if I get really, really up close to this microphone right here, I could probably make this thing work. But I would literally have to be putting this microphone in my mouth, and I'm not going to do that. So, but it does work by tapping on it. Okay, and I'm going to show you that right now. Watch, I'm just going to use my finger. My finger, there you go. You see the light switching? Actually, let me turn this light off. You might be able to see it better. And now you can see the lights. And I'm just going to tap this microphone. Okay, there you go. And it switched with my finger. Tap. And switch. Tap again, switch, tap. Oops. Hold on a sec. Tap, switch, tap. There you go. Back and forth by tapping the microphone. All right. Now, even if I tap it on here, it'll switch. So the sensitivity is enough to be picked up by the chip in order to switch the outputs. And I think this is pretty cool actually, because now I've converted the push button portion of the circuit into sound activated portion of the circuit. And I'm pretty sure you guys, and myself included, have a lot of great ideas being able to, use the circuit with a microphone, because there are so many things you can do with a voice activated system. And now they do have chips, that will convert sound into different kinds of signals. But what I did here is I did it on a discrete component level. And anyways, you can see it in action here, okay? Now, I haven't added enough amplification on the stage here in order to make it sensitive. I didn't want to make it too sensitive because even as I'm talking right now, this thing would be switching back and forth. So I just made it sensitive enough so that it's able to be detected by a thump, and you could see how they switch, okay? And even actually with my finger does the same thing. Now, you don't hear no thumping with my finger, but it's still, the microphone can hear my finger, and it switches no problem. So I think this is just awesome, to be honest with you. I actually really love it. So let me put this down, and I'll show you guys the diagram real quick, and I'll show you what I've done here. So I'm going to turn the light back on, and just give me one sec. All right, here it is. Put this aside. Here it is. Now, you guys may recognize this circuit here. The top circuit is the alternate action push button, which I have in my video called Fancy Switching, if you guys want to go back and take a look at that. And what I've done is I normally had a push button directly across these 2 points right here. And I've removed that switch, as you can see from here, in favor of adding this circuit, which is on the right side of the module right there. Now, this circuit obviously is also not complicated. What you're looking at here is you're looking at the microphone, which is powered by the 4,700 ohm resistor. Supply is 5 volts. You have a blocking capacitor and a diode, a couple of transistors, and then the output transistors. Now, these transistors, they're wired one after each other, and basically what this does is it just multiplies the gain from one transistor times the gain of the next transistor, and so on. Now, these are NTE 199s. I believe the typical gain on these is roughly 80 or so, if I'm not mistaken. So if you consider that they're amplifying 80 times, that would be 80 times 80, which is 6,400 times. That's the amplification factor between these two transistors. And you need an amplifying stage for these electric microphones because although they're very, very sensitive, these things, if you put these things in a parabolic parabolic dish, and you aim that dish into the sky, you can probably pick up aliens talking on Mars. You know, this is this is how sensitive these microphones are. All right. But again, you'd have to have lots of amplification, make it extremely sensitive, and so on and so on. And you'd have to literally put it in a parabolic system to make these things pick up from miles and miles away. But anyways, I haven't done that, obviously. I just used a couple of transistors, a small amount of amplification. And this diode, I wanted to tell you about this diode. The only reason I added this diode is because I wanted to make sure that the audio waves coming from the microphone, the diode will only allow the positive going waveform to turn the transistor on. But honestly, you really don't need this. I don't even know why I put this in. So, you know, and it's an NTE 109. The 109 is similar. It's a glass diode. It's similar to the 1N34A, but it is not germanium. It's a silicone diode. I just used it because I had it in stock. That's the only reason. And again, you really don't need it. You can actually connect the capacitor directly to the base of the first transistor because this transistor will only activate on the positive going pulse anyways, all right? So the diode really doesn't make any difference. I guess it does in a way, yeah. It probably just ensures that it's only the positive going wave that is coming into the transistor, not negative, but really, you don't need it, honestly. Anyways, you can add it if you want, or otherwise just leave it out. And then at the output stage here, you've got a couple of more, I've got a couple of more NPN transistors. Now, even though these are both NPN, they switch the inputs to this gate. How did they switch it? Well, let's dive into this a little bit more, and we'll see how. These transistors, being both NPN, when a signal comes in from the last stage here, will turn them both on at the same time. Turning them on at the same time, you may think to yourself, you know, how is that possible by switching these on and off? Well, it does. The way it does it is by biasing them on or off. The biasing of the forward biasing or reverse biasing of these transistors comes from this circuit right here. And the way it does that is that if you look at the top circuit, the first gates, the input signal here versus the output signal, they're always alternate. In other words, if that's low, that's high, and if that's high, that's low. Well, let's assume that the capacitor is discharged. That means that it has a zero value on it. So the output of the gate must be low, because if there was a charge on the capacitor, it would have discharged through the resistor into the gate, and that would discharge the capacitor. So this would have a low value on it. This would obviously have a high value because they have to be alternate. So a high coming on this line, actually on the bottom transistor is applied to the emitter. That's not right for an NPN. A low value on the capacitor coming into the same transistor and a high on the emitter, this obviously is reverse biased. It will not come on, okay? Because you cannot have a low and a high. It must be high on the collector and low on the emitter in order for this to turn on. So this transistor is reverse biased to the power coming in from the circuit here. So even though the signal is turning this on, it's trying to turn this on, but it can't because the transistor is reverse biased. But the top transistor is reverse to this. So the high coming from the signal is going into the collector of this one, and the low from the capacitor is coming into the emitter of this one. So when the signal at the base comes in from the transistor and it goes high, the emitter is is obviously lower than the base, so there is a diode drop right across here, 0.6 volt diode drop higher on the base, which means that that this is forward biased. This transistor being forward biased turns on. So when it turns on, it connects the capacitor through the transistor into the input of the gate, and the output changes states. Okay, when that happens, the capacitor now sees a low condition, the circuit sees a low condition and here and a high condition here. Now that high recharges this capacitor, and the capacitor now has a high value. Well, the high value is now applied to the circuit again, and the low value here is applied to the circuit again. But now the low on this line and the high on this line reverse biases this one here, but it forward biases the bottom one, all right? Now the signal, when the signal comes in again, the only transistor that gets turned on is the bottom one because it's forward biased. And again, now the high signal from the collector comes in through the emitter here, and it goes into the gate and is applied at the gate, and the output changes states again. So this is how it works, all right, using sound. Now, you can obviously add more stages to this if you like to give you better amplification. You can also use an IC here. A typical IC for audio amplification would be LM386, and then apply the signal, output signal, to these components here. But you really don't learn nothing by doing that. You know, that's why one of the reasons why I like to build individual systems like this with discrete components. So I know what's going on at every point in the circuit, and I can modify it as I need to, even internally. You know, if this was an IC, there's not much I can do with it other than changing external values, but not internal values. This gives me the option to change anything I want discretely, and individual components. And of course, doing it this way also allows anybody who's beginning electronics or is tinkering or is trying to learn how systems operate, and and so on and so on. This is a perfect way of building your circuits to learn from, okay? And this is one of the main reasons for myself why I do it this way. And I want to show you guys because I know that I see the trend on YouTube that a lot of you guys want to know and are very interested in learning about how to wire systems up like this to make it work, certain ways. And by doing it this way, it gives you the experience to learn in more detail, deeper into electronics, other than just using pre-made systems for you. So there you go. That's the actual diagram, and the circuit is right here. And again, sound activated. Let me turn the light off here for a sec. Okay, sound activated, and let me try this again. I'm gonna tap. There you go. Tap. As a matter of fact, I might just increase the gain on this a little bit more because I want to be able to talk into the microphone and just say on or off. And when I say on, I want it to turn on. When I say off, I want it to go off. So, but right now I'm just tapping. And even though the gain is substantially high enough for the system to react to the tapping, it's still not high enough to make it sensitive to voice, voice or ambient sound or things like that. Because otherwise, if you make these things way too sensitive, it's going to react to any sound that it picks up, unless you use, for example, low-pass filters and set your bandwidth so that it's very, very, very tight, and it will only respond to certain frequencies. So by doing it that way, you can actually make it respond to your own voice, your own tone, or your own frequency of your voice, but that gets into a lot more complications of circuits. But anyways, here's the result. I've changed the push button into an audio input system to trigger the switch, simulated double pole, double throw switch on or off. simply by using a microphone. Okay, so I hope you guys enjoyed this one here. I really love doing this. I think this is just awesome. And I have a lot more great ideas now that I got this thing working, and I'm going to use a sound activated system for some other projects that I have in mind. And I will upload that as well shortly. So guys, let me know what you think. If you like this kind of stuff, let me know, and I'll keep it coming, because there's a hell of a lot you can do with electronics. You just got to put your mindset to it. So with that, I'll just stop the video right here, and I'll let you guys go. And just want to say thank you very much for stopping by, for watching the video. And do not forget to subscribe if you have not done so, and I will keep this coming for you. All right, this kind of stuff. So guys, have an awesome day. Take care, and we'll see you on the next one.